Exponential and logarithmic notation are equivalent, just like two sentences that say the same thing but in different ways. Exponential form, 2 to the power of 3 is 8. Logarithmic form, the log base 2 of 8 is 3. Same fact, just flipped around. It's like saying, my dog, Chulog, ate my homework last night. Versus, my homework was eaten by my dog, Chulog, last night. Different structures, same story. So when you see a logarithm, just ask, what power of the base gives me that number? These properties talk like that one friend who always tells you obvious facts you already know in a way that sounds deep and philosophical. You know the type. The kind who stares out the window and says something like, you have to let go of one to hold on to another. And you're like, yeah, Karen, that's just how hands work. Evaluating logarithms without a calculator reminds me of poor John Napier. He spent 20 years calculating logarithms by hand. Not these nice clean ones like log base 5 of 25 equals 2. No, he was working out the hairy ones. The kind that makes a computer sweat. So when you're evaluating something like log base 2 of 8, remember, you're standing on the shoulders of a very tired Scotsman who did it all with no tech and a candle. Back in Napier's day, multiplying two big numbers was like trying to do brain surgery with a rock. That's why he came up with logarithms. These three properties, the product, quotient, and power rules, were his math hacks. Instead of multiplying two numbers, he'd just add their logs. Instead of dividing, he'd subtract. And when he needed to raise something to a power, he'd multiply. His motto was, why break your brain with multiplication when you can just cheat with logs? Logarithmic expressions are the yogis of algebra. They stretch out when you expand them and fold inward when you contract. It's flexible math with inner peace, until someone forgets to apply the power rule, and suddenly it's less downward dog and more downward spiral. The change of base property has nothing to do with baseball, military relocation, or painting. We are not changing the base from water to oil. It's about translating a logarithm from one base to another. Most calculators only understand base 10 or base e. So when you're dealing with something like log base 2 of 5, your calculator just stares at you like, I don't speak that base. The change of base formula is how you translate that into something your calculator does understand. Logs are picky. They don't accept 0, and they definitely don't accept negatives. So always plug your answers back in and make sure your logs do not go berserk. Otherwise, you'll proudly circle your solution, only to realize later that your logs never approved. If you still believe logs are useless, I challenge you to solve this equation without them. 2 to the power of x equals 3 to the power of x plus 1. Good luck matching those bases. You'll be there all day trying to guess the answer while your calculator quietly weeps. This is where logs come in like professional negotiators, taking both sides, calming them down, and making the equation solvable. It's not magic. It's just math, with a lot more paperwork. Exponential growth isn't just a math model, it's a rabbit reality. In ideal conditions, a population of rabbits can double every month. That sounds cute, until it's not. In Australia, someone introduced just 24 rabbits in the 1800s. With no natural predators and lots of grass, they multiplied like, well, rabbits. Within decades, there were hundreds of millions of them. It got so bad that Australia had to build a massive rabbit-proof fence. So yes, this formula, y equals y naught times e to the kt, may look innocent. But if that k is too big and your subject is too fluffy, prepare for bunny apocalypse. This example is about a human population and the growth rate, k, is 0.01. Considering rabbit population doubles every month in ideal conditions, can you find the growth rate for rabbits? Radioactive decay might sound like a scary science fiction word, but it's actually one of the reasons we're alive today. Deep inside the Earth, radioactive elements are constantly breaking down. That decay releases heat, and that heat keeps the Earth's mantle molten. A molten mantle means a spinning, churning core, and that spinning core creates Earth's magnetic field. That magnetic field is like our invisible superhero shield. It protects us from deadly solar radiation and cosmic particles. So yeah, exponential decay isn't just math. It's why we're not all cooked by space rays. In the summer of 1903, Sir Isaac Factorton stood at the rim of Mount Etna with a group of physics students, smoke curling around his coat like the setup to something epic. As the mountain rumbled beneath them, one student nervously asked if all this chaos could eliminate life. Factorton didn't flinch. He stared into the glowing crater and said with a deep charismatic voice, "From the silent crumbling of atoms beneath our feet rises the shield that guards all life. It is decay, not growth, that holds the universe together." No one said a word. Mostly because the volcano was about to erupt and all the students were running for dear life.